Ordering rational numbers, lesson 4. So we're going to talk about and order some rational numbers, or I cans. I can compare and order rational numbers. I can use phrases like greater than, less than, and opposite to compare rational numbers. So make sure you have today's date, your I cans, page number, and you are ready to move on. All right, let's do some comparisons. So let's see if you can figure out each of these. Yeah, this would be a less than. 12 is greater than 19. What about here? Yep. What about 15 and 1 and 5 tenths? Yep, it's a greater than. What about here? Less than, because that 0 is in the tenths. That's a 2 in the tenths. What about here? Yeah, these are actually equal. This does have an extra 0, but it's in the thousandths place, whereas this doesn't have anything there, which is still 0, right? What about here? Yeah, so you have to think about these making them into an equivalent fraction. So this would be 4 tenths. Make that tenths into 40ths, so you have to multiply. That makes that 16 40ths. It's a greater than symbol. What about here? Yeah, the larger the denominator, the smaller it actually is, because here we've got the same numerators. And what about this final one? Yeah, you don't have to do any converting here. It is a larger than, or greater than, excuse me, because 16 seventeenths is a lot closer to 1 than 11 twelfths. You're talking about 17 pieces, 16 out of those 17 pieces, whereas 11 twelfths, 11 out of 12. So, well, this kind of goes opposite of what I was saying earlier with the denominators thing. It is 16 out of those 17 parts. So even though each of those parts are smaller, there's enough of them to make a difference comparing those two. Okay? All right. All right, let's compare some points on a line here. So we've got M, N, P, and R here. So which of these could we use to make a greater than? Yeah, we could use R is greater than P, R is greater than N, R is greater than M, P is greater than N and M, N is greater than, sorry, my mouse is acting a little funny. Oops, hang on. Okay, but I could have used any of these to compare with any of the previous ones. Nothing's greater than R, though, in this situation. What about less than here? Yeah, I could use any of those, but I'm going to use P is less than R. Again, why? Well, it is further to the left. Which of these are opposites of? Remember, opposites are the ones that have the same digit. One is positive, one is negative. That's M and P. Because M is at -5 and P is at 5. And negative number. Yeah, you could use M, you could use N, whichever ones you wanted. Okay. Let's just do one of these real quick. So if point P is at 2 1/2, oops. Hang on. What would these other points have to be? Well, we just said that P is, or M and P are opposites. So M is, -2 1/2, right? because if they are the same number of hash marks away, then they've got to be equal as far as the digits. It's just one's negative and the other one's positive. So if that's 2.5, each one of these has to be 1/2. So if this is 2 1/2, 3, 4, 2 1/2, 3, 3 1/2, 4. So R is at 4. What about here? Yeah, N is at -1, right? Because if each one of those hashes is 1/2, two of them would make -1. All right. Let's try another one here real fast. We got N in this situation is -4/10. Okay, so if that's -4/10, what are the rest of these? Well, that means that since this is 2 hashes away, each one of these should be 2/10, right? So 2/10, 4, 6, 8, 10/10, or -1. If that's -1, P is 1. And if P is 1, then R is 1 2/10, 1 4/10, 1, and 6/10. So even though it looks like you could easily say these are any number, and back here when they were talking about opposites, we could just say that they were 5 and -5 because you could just go with those as being just straight whole numbers each. But we could easily use these as different parts of numbers. We're not going to talk about all these because these, if we'd been able to do partners on this. But here where it says, how can we tell if two numbers are opposites? Pretty simple. If they have the same digits, one has a negative, one doesn't have anything with it, which means it's positive, then they're opposites as long as they have the same ones. How can we tell if one number is greater than or less than another number? Well, any number that has another number to the left of it, that first number, if the number is to the left of it, it's greater than that number. If the number is to the right of it, then it is always less than that particular number. So it really is just a matter of paying attention to where it's placed. So what are some situations where negative numbers make sense? So I think the easiest one that everyone usually relates to is weather. So 0, especially if you're talking in countries that use Celsius, is the point that water freezes. We use 32 degrees Fahrenheit in the United States, but we still have, on occasion, temperatures that are below that, and even go below 0, make negative temperatures, especially if you go further north in the country. So in those situations, negative just tells you you're that much further below a certain temperature threshold. If you're talking about 0, with the weather, Fahrenheit, 0 is very cold. It's much colder than water freezes. If you're talking about 0 in Celsius, then you're talking about the exact number where water freezes. And that negatives then means anything that's colder than water would freeze, and positive would be someplace where water would be back into at least the liquid state if it didn't turn back into a gas. With Fahrenheit, though, it's a little bit different, but still, 0 is a much warmer temperature, relatively speaking, than like -15. And a lot of times if we get wind chills, those with the wind blowing and it's cold already, tends to bring their temperatures down further. So what about a number line? What does positive mean and what does negative mean? Well, when you talk about a number line, anything to the left of that 0 is a negative number. Anything to the right is a positive number. So as you go further left, you're talking about things that are smaller and smaller or worth less and less. As you go to the right, they get to be worth more and more. 0 is not positive or negative. It is the balance point to which both of those come to. At 0 is where you have that dividing line between positive and negative. So it's really just that central figure. It's not positive or negative. It's just 0. So I think we've talked about opposites pretty well. You know that when you talk about an opposite, it is something that has both a negative and a positive that's the same number. It's just that one of those is a negative and one of those is a positive. And that we don't write the positive with it because we typically use positive numbers in day-to-day life much more often than we use negative numbers. Not that we don't encounter them. What about what's the opposite of 0? Yeah, 0 is a weird one. 0's opposite is 0. Why? It doesn't have any other digit. It's a mirror of itself already. And we talked about this, how you can tell if one number is greater than another number. On a number line, wherever you're talking about your number, let's say we pick a number right here. It doesn't matter what the number is. So this is our first number, okay? If our second number is anywhere to the left of it, it's less than, this is greater than it, right? So any number that falls to the left, you're going to know that in a comparison of A and B, and it doesn't matter what number it is, the only point we're trying to talk about here is that if I have A and that I have B anywhere to the left on a number line of A, then that A is greater than. If you talk about a number line and you have A, it doesn't matter where A is, but in this situation we're going to have it here, and you have B is anything to the right of it, then this comparison is a I cracked myself up. A less than situation, right? Because the further left you go from something, the smaller in value it is, and further you go right, the greater in value. So even though both of these are negative, the fact that A is to the left of B means that this is a less than situation. Here it's the opposite. We have A to the right of B, so that's why this is a greater than situation. All right, that's it for today. Thanks for watching.